Number 7. Oh man, look at this funky function. Okay, here we're supposed to find critical points. That's what we're looking for. So what we have to do is we have to find where the f prime for this function is equal to 0 or where it is undefined. So let's first find f prime. Oh man, this is weird. It has an absolute value in there. What? Okay, so that means we're going to treat this like two different functions. We're going to treat this like as if this inside was positive. And we're going to treat the function like it's negative, and we're going to find f prime of both of these for both of these. So this would be negative x minus 2. So we have two scenarios here. We have if the absolute value is positive inside or if the absolute value is negative inside. And we could have just put the negative out here, I suppose, but I distributed the negative. All right, so I'm going to go ahead and multiply this out and then take the derivative, because if I don't have to do the product rule, I'm not going to do it. So I get x squared, be negative 2x, and then minus 8. Now you have to do foiling or distributing. You go that guy times that guy times that guy, and that guy times that guy, and that guy times that guy. So you get 4 terms, and you have to combine like terms, and that's what you get when you simplify. Let's see the other one. We would get negative x squared, and that would be positive 4x, and then finally positive 8. All right, so let's find f prime of each of these. So we have f prime of x equals 2x minus 2, and then wait, that one gets a 4. No, that's not 4. That's supposed to be positive 2 in the middle. Sorry, my fault. Hopefully that didn't throw you guys for a loop there. Okay, so f prime over here, we got negative 2x and then positive 2, so we're slightly different here. So these guys equal to 0. We get 2x equals 2, so x equals 1. And then over here, let's see, we got equals 0. Move the 2 over, we get x equals positive. What? We get positive on that one too? I guess we do. All right, well, that's kind of neat. So right now I just have one critical point, and it's at 1. But is there anything I can plug into this to make it undefined? Nope. All right. We got to pause here and think for a second. And the reason why we got to think for a second is because of these absolute value bars. Okay, so we worked this out both ways and just found that we got x equals 1 for a critical point. And then if I look at f prime, I'm not seeing any value that would make f prime undefined. But we know what absolute value functions look like. And if we were to just look at a regular absolute value function, it goes like this. And what do we have right there? We have a point. And the slope is undefined right there at that point. So if we consider this equation, if I just consider this part of the equation, that would be shifting to the function to the right too, but we would still have a point right there. And if we were multiplying it by another number, like whatever this is, and then we multiply it by a number, that's not going to change this point. Oops, I'm sorry. Just realized that I went the wrong way. 1, 2. So if we were to just graph x plus 2 absolute value bars, that's what we would get. So there's something happening right here at negative 2. We have an undefined slope right there. And just to show you more, to confirm this, let's look at the graph of both our functions that we got when we did the positive and the negative version of x plus 2, and then the actual function. So you'll see the function that the problem gives us in blue, and then you'll see our two functions right here in red and black. So here we go. There's the blue function. Look, see right where negative 2 is at? We have a sharp turn right there. So that's, you know, how you guys can see that there's no slope right there. So that means our critical points are at negative 2 and 1. And I don't need to do the signs on this because this problem doesn't ask for a maximum or minimum. So this problem is done.